You can use this video to test yourself and see whether you really understand the difference between offense and defense. Before you watch this video, I recommend that you watch the previous video in which I explained that difference. There's a link in the description. First, we're going to need to learn how to use Euler diagrams. Here's the most basic Euler diagram. It only has two circles. You can see that this is a slightly modified version of a Venn diagram, and it has 5 distinct sections, and we can actually number them like this. The first section is the entire orange circle, and you can see that it contains 2 subsections, subsection 3 and subsection 4. The second section is the blue circle, also containing 2 subsections. The third subsection is this crescent-shaped like section, which is all of the orange circle, which is not included in the blue circle. The fourth section is the overlap section. That's the section that's in both circles simultaneously. And the fifth section is the crescent-shaped section, which is part of circle 2, but not part of circle 1. We can use the relationships between those 5 sections to illustrate the relationships between different sets of objects. And before we apply this to debate, let's take a simpler case. Let's say that there are 5 sets. The first set is a set of all humans. Then we have a set of all dogs, a set of all birds, a set of all two-legged animals, and finally a set of all mammals. What I'm going to ask you to do is to draw this Euler diagram in your notes and then try to label it using those 5 words. You can pause the video now. Now that you've unpaused the video, let's see if your answer is correct. Here's the correctly labeled Euler diagram, and from this diagram we can make 5 conclusions. The first conclusion is that a human is a two-legged mammal. Let's see why that's true. Well, here is the human. The human section is the overlap between these 2 circles. The first circle is all mammals. The second circle is all animals with 2 legs. Because a human is part of both circles, that means that we know it's a two-legged animal. The second statement that we can make is that dogs have more than 2 legs. Actually, from this diagram, it's possible that dogs have fewer than 2 legs. But the one thing we do know for sure from this diagram in particular is that their number of legs is not exactly 2. And we know that because the dog is outside of the circle that contains all the two-legged animals. The third statement we can make is actually logically very similar to the second statement. It tells you that birds are not mammals, and that's because birds are outside of this orange mammal circle. The fourth statement we can make is that humans and birds both have 2 legs, and that's because both humans and birds are the 2 sections inside of the larger blue circle that shows us all the two-legged animals. And fifth, we can say that humans and dogs are both mammals, which is the same logic as the one for statement 4. Here you have a dog, here you have a human. Those are the 2 sections of the orange circle. Now that we've seen how the Euler diagram works, let's try to apply it to debate jargon. And we're going to take the 5 words that we've learned in the previous video. First, there's offense and defense, and those are both spelled with an S because we won the Revolutionary War. Then there is on case and off case. Well, by case, we mean the affirmative case. So on case arguments are arguments that the affirmative first presents in their speech, and then also arguments that the negative is using to directly respond to the affirmative case. But the negative, in addition to directly responding to the affirmative case, can also make arguments that are off the case, hence off case. In the previous video, we called those arguments disadvantages, and we called the on-case arguments made by the affirmative advantages. And in the most basic round, that is how we would label these. But as you start looking at more complicated rounds, you will see examples of other off-case arguments that are not disadvantages. You can have critical arguments, and you can also have theory arguments. And so we're going to use this more general term in this video. Finally, we are going to have a turn, and a turn is just an offensive argument that is made as an answer to an on-case arguments, those in an answer are usually to an advantage. And the one thing that's important to remember, just like in the previous video, we're going to be looking at this from the perspective of the 1 and C, the first negative constructive. You could apply this to other speeches as well, but the 1 and C is the most straightforward case study, and so that's the perspective that we're going to adopt. All right, let's bring out the Euler diagram again. So here's the diagram. You should go back to your notes, copy down this diagram again, and then try to label it using these 5 debate terms. You can pause the video now. Now that you've unpaused the video, look at your notes and look at your Euler diagram, which is now labeled, and see if it looks like this. And if it does, then you are wrong. This is, however, a very common mistake, so let's analyze exactly what makes it wrong. The first problem with this way to label a diagram is that it shows the defense circle and the offense circle as overlapping. But we know that can't be the case because defense and offense by definition are mutually exclusive. An argument is either offense or defense. It can't be both. And so if we were to represent those two sets as circles, those circles could not overlap. They would have to be completely separate. People might say, but hold on. An on-case argument could be either offensive or defensive, so wouldn't it make sense for this overlap section to be part of both the defense and the offense circle? The problem with this kind of thinking is that any one particular on-case argument has to be either defense or offense. This diagram actually shows the relationship between on-case arguments and defensive arguments exactly backward. If we think of defense and on-case arguments as two circles, this would be the wrong way to represent it. It's not that on-case arguments are one kind of defensive arguments. It's actually the other way around. Defensive arguments are a type of on-case arguments because there are on-case arguments which are not defensive, namely terms. So now let's go back to the Euler diagram, and if it didn't work out for you the first time, try again. Try to label this using those 5 words. You can pause the video. Now that you have unpaused the video, let's look at the correct answer. And the correct answer looks like this. And just like the last time that we looked at the Euler diagram, this answer can tell us 5 things. The first thing this can tell us is that a turn is on-case offense because a turn, which is in the overlap section, is both part of the on-case circle right here, and it's also simultaneously part of the offense circle. The second statement we can make about this is that defense is not offense. Unlike the previous time when we had those two sections overlap, here there is no overlap. You have defense as this crescent-shaped section, which is entirely outside of the offense circle. Then, the third statement we can make is that off-case is not on-case because an argument can only be in one place at the flow at a time, so if it's on the affirmative flow, then it shouldn't simultaneously be on the negative flow. There is one exception to this. We can have cross-applications of arguments where, for example, an off-case argument can be cross-applied to also take out some argument on the affirmative case, but this is going to complicate matters, so we're going to put that aside for now. The fourth statement that we can make is that the two types of on-case responses are defensive responses and turns. So in this on-case circle, we have the defense section and then we have the turn section. And an important corollary to this is that you can see that defense is very clearly different from off-cases. Because off-case defense is pointless. There's no reason to bring out an entire off-case and use your time just to point out that there is some impact that neither side is winning. So if you're going to bring up an off-case, it better give you some offense. The fifth statement that we can make is that the two types of offense are off-case offense and then turns. And so we have off-case offense right here, and then we have turns, and turns, once again, as we recall from statement number 1, is just the kind of offense that is on-case. Now that we have labeled this Euler diagram, let's think about how this relates to the graph that we've learned in the previous video. And let's put those two side by side. And let's think about how this graph can be used to illustrate those same 5 statements. The first statement, a turn is on-case offense. Well, first of all, we can clearly see that a turn is on-case. It's talking about an on-case impact. How does this graph show offense? Well, given that we're talking about negative arguments, offense for the negative is anything that brings us to the negative side of the axis. And if we look at this turn, we can see that very clearly it lands us on the negative side, so it is offense. The second statement, defense is not offense. Well, let's look at defense. Defense is just this one arrow here. And does it land us on the negative side of the axis? No, it does not. It lands us on the affirmative side of the axis. It might mitigate the affirmative's argument, so it might say that we're not as far down the affirmative side as we would have been otherwise, but it doesn't actually take us to the negative side, and therefore is not offense. Okay, third statement, off case is not on case. Pretty straightforward. All the on case arguments are right here. All the off case arguments are right here. They don't overlap, just as we want it. Then, number 4, the 2 types of on-case responses are defensive responses and turns. Well, let's look at on-case responses. The affirmative makes the original argument. The negative can make 2 direct responses to this. Here we have the defense that takes us part of the way back. It could even take us all the way back and be terminal defense, but it's still not a turn. A turn takes us past the midpoint into the negative territory. And finally, we have the 5th statement. The 2 types of offense are off-case offense and turns. Well, again, what's a turn? It's anything that brings us to the negative side of an axis. Well, we have a turn that brings us to the negative side of an axis that represents on-case impacts. But then we also have off-case offense, and that takes us to the negative side of an axis that represents off-case impacts. So far in this video, we thought just about the first negative constructive. Can the same logic be applied to all other speeches? Yes, it can, but if we want to do that, we can no longer use terms like on-case and off-case, because those are specific to the negative. From the affirmative perspective, on-case is the affirmative's own arguments rather than something that the affirmative would need to respond to. So if we wanted to make a more general version of the Euler diagram, we would need to replace the word on-case with just answers to the opponent's case. Now, answers to the opponent's case from the negative perspective are the on-case arguments, but from the affirmative perspective, those would be the off-case arguments. And then, of course, anything which is not an answer to your opponent's case would have to be your own case or whatever additions you made to that case in later speeches. Then we can relabel the 2 graphs on the right accordingly. Until next time.